Okay, hello Budapest. Thank you to HUSTEF for inviting us to give this talk. I have personally a long history of coming to Budapest, so I'm very thrilled out of all places to be able to share this in this beautiful city. So I wanted to meet my colleague Syam. My name is Martin. We're both working for a company called Carousel in Singapore. It's a classified marketplace, similar to like OLX. We had a presentation yesterday from Alexandra from OLX, so that's the same industry. Or maybe in Hungary there is a marketplace called Spock. It's quite popular in Europe, so if you sell your stuff or buy stuff secondhand, you might have come across this. So in our case, for Carousel, our mobile apps are very important. It's a mobile marketplace. We have a web version as well, but we focus more on mobile. So a question for us became, what is a good way to test our mobile apps from a UI point of view? So humble beginnings, we decided, okay, let's build a device farm to get from doing manual regression tests for every release, every week, which was a lot of work for us as testers, to do automated regression tests. And probably, you know, like startups like Carousel, they have this thing of naming everything based on the company name. So we call our employees Caro Fam because we're one big family. We don't celebrate Halloween, it's Caroween. So in the tradition of this and lack of having a better name, we call this our Caro Farm. So it was basically a very simple hackathon project that we did with a Mac Mini, 2 Android devices, 2 iOS devices. And the cool thing is it worked fine. It had some small issues, some technical problems, and also like practical issues, like people seeing this and like saying, I need a device to test something. This iPhone looks cool. They unplug it, run away, and the next day you come, check your test results and wonder why the hell half of our tests are failing. So we knew we had a long way to go. Before we talk about this, just a very quick background, what is our tech stack? So we have a test framework written in Java based on Selenium and Appium. We use Cucumber for our test scenarios and page object patterns, so pretty standard basic stuff. Maybe one cool thing about our framework is, we're able to reuse all the scenarios across all different platforms. So whether it's Android, iOS, or web, it's the same Cucumber feature files because from a functional perspective, it doesn't change. That will become important later. And then to execute all this, we use Chrome for the web part and the Appium server that instruments mobile devices on the mobile side. And this is more or less the area that this talk is going to focus on. So when we finished this first little project, we presented to our management and said, hey, that's pretty cool. We save probably 40 to 50 hours for every release. And since we release weekly, that's a pretty big deal in manual testing effort. And we run these tests for our weekly regression tests. And I think as any good manager, they want to push us a little bit harder. Say, you can do better than this. We need to run these more frequently. And we thought at this time we are ahead of the curve because we said, yeah, basically we run them every day anyway. But they weren't happy with that either. They said we need to think a little bit bigger. We need to have a big, hairy, audacious goal. What about running UI tests for every code change? So we already run unit tests and integration tests for every pull request. Why can't we do something similar for UI tests? Because there are some sort of bugs that we had that are very hard to capture with a unit test. For example, the logging mask not showing up or the sell button is not working properly. Those are hard to catch with other tests unless you have some UI test coverage. So the idea was developer creates a pull request, sends it to GitHub, then it comes to our device farm. We run a subset of our regression tests, and then it's basically a build pipeline, so it's either red or green. If there are test errors, it goes back to the engineer, and he will work on his PR until everything passes and the change is good to go. But yeah, that was all good so far, but then the catch is, guys, the whole thing should finish within 20 minutes. So the goal was to run roughly 20+ functional UI tests with a turnaround time of 20 minutes. So I remember going out of this meeting like, this is a cool idea, but will we be able to pull this off? There are a couple of challenges. One is that the load is fluctuating. Sometimes you don't have a lot of pull requests. And especially when code freeze comes closer, there will be multiple pull requests that you need to verify simultaneously. But the even bigger and more pressing immediate issue was that 20 minutes is quite damn ambitious, especially if you consider for iOS, even building the app package that you want to test based on that pull request on our Circle CI build infrastructure took 15 minutes, which just leaves us 5 minutes for the testing. So we realized, unless we come up with something, we need to run in parallel quite heavily. And we cannot wait for device to be available. When we have a pull request, we need to have the devices to start testing right away. So here are some of the parameters for what we were trying to build. So we wanted to have a solution that we can have for all our platforms. So Android, iOS, and then later also for the web. We wanted to keep our existing tests. So we had a number of like 150 regression tests, and we wanted to use a subset of this for these pull request verification, or how we call it, fast feedback tests. At first, it was a static subset, like the 20 most important test scenarios. But then later, we want to be able, based on the pull request and the code it touches, to have our solution pick the most suitable test cases to verify the change. The third one is probably the controversial one, where some of you might disagree. We decided we want to keep our test framework platform independent, so we didn't want to go for native automation like Espresso or XUI test, which might be faster, but then you need to rewrite a lot of our tests. We wanted to at least give it a try to reuse what we had written in Appium. And lastly, we decided, okay, let's try this, do a POC, but try it for iOS first, because what we learned from mobile development, you do something for Android, it works more or less fine, then you try to replicate it for iOS, and you run into all sort of interesting issues just because, yeah, Apple is a little bit different sometimes. So we decided we'd try the hard one first. So we were standing at this crossroad, and where to go from this small device farm. So basically, there are two ideas. Either we can just go from 4 devices all the way up to 40, or then even more, and scale this ourselves and host the devices on-premise. Or the second one, we get a cloud provider that offers testing devices as a service, like AWS Device Farm, Sauce Labs, Browser Stacks. There are a couple of those. And we looked into the pros and cons. I keep this short here. Basically, there were 2 showstoppers for both solutions, and that was cost. We didn't see how we can scale this in any way that is within our budget. Because maybe we want to start with 30, 40 devices, but a year later we might need more. We want to use that for regression tests as well, for other types of tests. Number of teams will grow, number of engineers will grow. We have more and more PRs to verify. So this is not really going to scale. And the same for doing it on-premise. You need to buy new devices. You need to maintain everything. You need to maintain devices 24/7. So we said we're not going to do this. And then at some point, I saw this, I found this table on one of the cloud providers' webpage, and they're actually trying to make a point why you should always test on real physical devices, because certain things you can only test on physical devices versus simulator or emulator. But I read that differently, and I understand, okay, if you have a virtual device, like an iOS simulator or an Android emulator, the only thing you can test is the basic app functionality and UI layout. But for our use case, that was actually exactly what we needed, and it was all we needed. So we realized we don't have just 2 options, we actually have 4 different options. And maybe using virtual devices in an on-premise setup is like kind of the sweet spot that would solve our problem. So here's the plan. We decided okay, let's build an iPhone device lab on-premise, so we host it on our own hardware, but use simulators instead of real phones. And it just so happened we had a bunch of old MacBooks lying around the office from previous employees who left. Okay, we don't need to invest in hardware, we can do a POC on that. Because for iPhones, anything you want to do in mobile testing on iOS, you need Apple hardware. You cannot run it on a Linux or a Windows machine. So that was quite useful for us, and Syam's going to tell you a little bit more about how we actually built it.
Yep. Thank you, Martin. Hello, myself Syam. I'm from India, and currently I live and work in Singapore with Carousel. So, how to go back?
Red one.
Sorry. Yeah. So I'm also one of the co-organizer of Tequila. Tequila is a QA meetup group in Singapore. So let's have a look at which are the tools that we have used to build the Terraform. So Martin already mentioned that we are using Java with Cucumber. So apart from that one, we are using Selenium Grid for parallel execution. And since we are dealing with mobile application, we are using Appium. Also, Jenkins as the continuous integration tool. So last but not least, we are using Ansible. Anyone here use Ansible in your organization? Cool. So if you don't know what's Ansible, it's basically using for IT infrastructure automation. So let's say you have 100 machines in your office, and you want to restart all the machines exactly at 6 a.m. in the morning. You can do it with single line of Ansible code. So basically, it works based on SSH. And this is how the inventory file look like in Ansible. So we have two types of machines, MacBooks with 8 GB RAM and MacBook with 16 GB RAM. So we have provided the IP address of this machine. And the last one, we exclusively using for the grid. OK. So how does it work like? SSH should be enabled for each machine. And Ansible can execute any command on all these machines. This is how a typical YAML file look like. This is an example of how we are killing the Appium server on each machine. You will see that the host mentioned as Mac 8 and Mac 16, so which means that it will be executed in all the machines which is defined inside that section. Okay. So how does it work? We have a script killserver.sh, and you can see the command how it's going to kill the process ID of the Appium server. So it will collect all the Appium server process ID, and it will kill one by one. So if you want to start, you can do the same command. Instead of killing it, just start it. So that's how it works. This is a high-level overview of the architecture. You can see that there are multiple modules like configuring the Appium. If you have ever worked with Selenium Grid, you know that you need to create some JSON files for the nodes to create it. So Ansible will do everything for you. So Ansible can find out what are the simulators available inside the machine. And it can find out the UDID of the machine, and it will create the JSON file for you. So it can start the hub. It can start Appium server. It can kill Appium server. It can download the test build. Occasionally, it can restart the entire MacBooks. So how do we do grid setup with Ansible? So like I mentioned earlier, let's say we need to configure the JSON file, right? So how Ansible going to work here? Like Ansible can fetch all the simulator information in the MacBook, which are available test simulators in the machine, UDID of the simulator, OS version of the simulator, everything it can fetch. And it can create a JSON file for you, which is needed for the Selenium Grid registration. And if you want to kill, starting the Appium with node config, so you already created the JSON file, and you can mention that configuration over there, so that when you start the Appium server, it will be registered to the Selenium Grid hub. And you can kill it also. Yeah, so we were not using the Selenium Grid in its pure form. We have done a few customization over the Selenium Grid. Likewise, we have identified that, let's say, I search on a 16 GB machine, we can use maximum 8 simulators in an optimal way. Okay, so if you are using more than that, there will be some performance issues. So we identified that each simulator is going to act as one node. And we will have unique Appium server, which is registering for each simulator. Then we have implemented the custom capability matcher, which means that, let's say I have a test, and I want to execute my test on a specific simulator, which is on the particular machine. So I can do that. The only thing I need is to get the UDID of the simulator. So when I instantiate my driver, you just need to give the UDID. Then it will pick up from the Selenium Grid. It will start executing over there. So some custom servers also there, so which will give you the information on what are the available ID, what are the busiest simulator node, and every information you can get via the custom servlet. To add more MacBook into the farm, it's quite easy. You don't need to install everything from the scratch. What you can do, you can just do time machine backup, and you just need to add the IP address to the inventory file. That's the only thing required. There are some challenges that we have faced, like to get the correct build. So we are actually, once the build available, we are saving it in the GCP bucket, and Ansible script will be downloading and distributing to all the MacBooks available. Then we decided we will handle maximum 5 pull requests at the same. If the 6th one is coming, it will be in the queue. Then we are periodically restarting the Appium server to avoid the issues. Then we have a script to check whether Wi-Fi is available. Then if it's not available, it will try to automatically reconnect. Then we have implemented the VPN in all the machines so that you can access all the machines from the home. Then the video recording, so we are using the default Appium video recording, so it's always better than the screenshot. We have a demo for you guys. Could you please play? Volume up. Volume. No volume. Sorry, there is an audio. I will share the video with you guys later. Yep.
Yeah, sorry guys, the audio was not working, but basically the idea is developer pushes a pull request, goes for a coffee, comes back from a coffee break, everything should be done. That's where the 20 minutes came from. So here's just quick vision, what are the next steps we want to do or are currently working on. So we showed what we did for iOS. We built the same thing for Android and chose slightly different architecture. So instead of Ansible, we're using Docker because Android emulators are quite easy to run within a container. And also instead of Selenium Grid, we went for a queuing approach. Sorry, I don't know why this is not working. Okay. So also the next step is, so we have iOS, we have Android. We might want to add a couple of physical devices because we have some test cases that require a physical device, not so much in our pull request suite, but for the full regression. And lastly, we also want to integrate some of these cloud providers. So right now we're using one of them for our regression tests. And the end goal is to have Carol Farm be like the initial queue for all our test cases. So when we execute a test, we have a test definition. We say, OK, this is the required device type, either physical device or virtual device, maybe add some priority. And then the Carol Farm acts as a queue, which decides which device to send the test to, and then aggregates all the results and gives us a test report back. So this is the big picture that we are working on. So yeah, that's all we have. We're happy to take your questions. Thank you very much.
Thank you very much, gentlemen. And now let's see the questions from the audience.
Yeah, I'll take the first one. What about real devices on AWS or Browser Stack? You can execute tests on real devices using those providers. So we actually tested almost all the cloud providers that are out there. And the ones we looked into in more detail were AWS Device Farm and Browser Stack. So for AWS Device Farm, one of the issues is it has a very long ramp-up time. So when you want to prepare a device to run a test on it, you need to wait almost 2 minutes. So the setting up and tearing down is way too slow for the use case that we have. It's fine for regression tests where it's not so time critical, but for what we were doing here, it was just not acceptable to wait so long. Also, there were certain issues with AWS where you need to wait for a device, which is not available, and then it screws up your whole pull request verification pipeline. Browser Stack, actually using that for our regression tests. The only issue that we have here is it's just quite expensive to do it at scale. So if we had unlimited budget, probably that's an option we would go for. But we cannot afford to have 100 or more devices on these services. And we need to be prepared for the spikes when you have multiple pull requests coming in at the same time. And then for that, we need a high number of devices. And then maybe the rest of the time, we cannot even utilize them. Because they also don't have very flexible billing schemes where you can model these sort of use cases. Okay, next one. How do we deal with connectivity issues? You want to take that?
Yeah, so I assume connectivity in terms of connecting to the simulators or the test devices. So basically, we will have retry mechanism in the framework. Also, we will wait till the simulator available for execution. So we have logic to handle this in the test framework code itself. So we will start the execution only when a particular test simulator is available for the execution.
Okay, how do you cover all capabilities? Do all tests runs in all configuration possibilities, or do you divide somehow? So for the pull request verification, we don't actually care so much which type of device or which OS version it is, because we just want a very quick feedback if some basic functionality is broken. So for this use case, we only use one fixed set of devices, so just one specific type of iPhone or one Android device, which is a Google Pixel in our case. For regression tests, we actually run it on multiple different form factors. Have you thought about mixing cloud-based test devices with real hardware in your test setup? Yeah, so that was the last slide, the overview of our vision was about. So that's what we're currently working on, to be able to use both cloud-based and local devices as well as virtual devices, simulators, emulators, for the same test execution. So whichever devices are available, that's where the tests are run on.
Okay, next one, how do you create a test report? So basically, we have integrated the test rail services to our framework. So whenever there is a test execution, we will be getting a corresponding test rail report. And the test rail report will have all the necessary information like the log file attached and the video recording in terms of if any of the execution failed, and you get overall report from there. So it's completely independent of the project. So it will read from the capabilities that provided against which build it has been executed, on which simulator it has successfully run. Every information you can find it on test rail. So once it's successfully run, we will be getting a Slack notification. So we will be giving the link of the test rail over the Slack message, so the team can view it from there.
Okay, next one. How do you deal with firmware upgrades?
You want to take it?
You want to take this one?
No, you can.
Actually, for simulators, we don't really deal with that at the moment. How do you deal with Appium server flakiness? So one thing we do is like there's a one-to-one relation between a simulator and an Appium instance, and the second thing is we restart them frequently. yeah, I guess we're running out of time, so I guess enough said then. Thank you very much. Yeah. If you have any more questions, feel free to find us.